Betelgeuse or Betelgeuse, it's a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. It's enormous, it's very unstable, it's about to explode. They are among the biggest explosions of radio energy in the entire universe. They generate more energy than a billion suns. Betelgeuse or Betelgeuse, it's a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. It's enormous, it's very unstable, it's about to explode. When we think of stars, we probably imagine tiny shiny items in the night sky. At least this is how we see them from down here on the planet. But stars are something else entirely. In fact, one of the biggest stars, Betelgeuse, happens to be much larger than our Sun. For years, this star has baffled scientists, but recently something more unsettling has been happening with Betelgeuse, making scientists and other well-informed folks very, very concerned. Join us in this video as we explore the terrific news about Betelgeuse, its impending destruction as expected by the James Webb Space Telescope, and how this new development will affect our galaxy and our lives right here on the planet, as explained by physicist Michio Kaku. Betelgeuse is a cosmic wonder, a large star that has intrigued cosmologists for so long. A Greek astronomer named Tony was the first to discover it. This star is so huge that it can be seen in the night sky from Earth, particularly during winter. If you're into constellations, you've probably seen or heard of this star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and so far one of the brightest stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay constant. Instead, it fluctuates. This fluctuation is one of the unique properties of the star, but it isn't the only one. Let's look at some of Betelgeuse's specific properties. Most of the stars you see in the night sky are actually far from Earth. The nearest star is 4.2 light-years away from Earth. If you don't understand how the term light-years explains distance, picture it this way. Consider moving at the speed of light for a whole year. It's been proven that light can cover a distance of 186,000 miles per second. Therefore, the distance light can cover in a year is equal to 1 light-year. If you do the math, you'll have billions of miles. So when we say the closest star is 4.2 light-years away, it means it is billions of miles away from Earth. But guess what? Some stars are even farther, and Betelgeuse is one of them. Betelgeuse is located approximately 600 light-years away from Earth, so if you were to travel to it at the speed of light, it would still take 600 years. We can't move that fast. Not even our fastest spacecraft can. But this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so bright despite its distance, that's because of its other qualities like size and brightness. Betelgeuse is about 500 times larger than our Sun. Its radius is believed to be about 1,000 times that of the Sun. It's so big that it appears as a disk in space when using sophisticated telescopes, while other stars appear as little points of light. This appearance is suspected to be an effect of the reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse measures about 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equal to 2 times 10 to the power of 30 kg. Scientists cannot determine the exact mass of Betelgeuse because there are no other planetary bodies orbiting around it to compare with, and of course we can't measure it directly from here on the planet. But it's proven that this star is at least 12 times heavier than our Sun. The brightness of Betelgeuse ranges from magnitude +0 to +1.6. In more familiar terms, Betelgeuse is 16,000 times brighter than our Sun. No wonder it was nicknamed a red giant. However, the brightness of Betelgeuse doesn't stay constant. It fluctuates. This fluctuation is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter, but when it contracts, it dims. This process can last for 10 to 100 days or even more. One unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these regions is far stronger than at the normal surface, but the downside is that these strong magnetic spots inhibit the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has lots of these spots compared to our Sun explains why it is cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and very numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is 1,000 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on the surface of Betelgeuse appear to be in loops or arcs. Betelgeuse has a surface temperature of about 3,500 Kelvin. This low temperature contributes to the low energy emitted by the star and its dim red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish about 2 million years ago, just like our Sun. Over the years, the color started changing to orange, red, and then, about 2,000 years ago, it slowly started becoming the red star we know today. This fact has made scientists believe that the star is aging. Betelgeuse emits as much as 7,500 times more energy than the Sun. It would have been a fierce rival to Earth's Sun if it weren't so far away. In its prime, the fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite remarkable. Our Sun is only 8.3 light-minutes away from Earth. That's why it's so powerful. If Betelgeuse were just slightly closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would swallow up or displace the Earth and the other 4 planets near it because of its enormous size. Furthermore, even if it could match it, it emits more radiation than our Sun. Betelgeuse, also known as Betelgeuse, is a supergiant star located in the constellation Orion, approximately 600 light-years away from Earth. Its immense size is one of its most striking features. It is about 500 times larger than our Sun in terms of radius and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This colossal size allows Betelgeuse to appear as a distinct disk rather than a point of light when observed through powerful telescopes. Unlike most other stars, despite its enormous size, Betelgeuse is not the most massive star. It ranges in mass from about 12 to 19 times that of our Sun. This variability in mass estimation is due to the challenges in accurately measuring the mass of stars that lack a companion star or other objects to provide gravitational reference points. Nevertheless, even at its lower estimated mass, Betelgeuse remains a significant stellar entity. The brightness of Betelgeuse is another noteworthy characteristic. It varies regularly over time, with its brightness ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be 16,000 times brighter than our Sun. This variability is attributed to its pulsations, periodic expansions and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for days to months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct reddish-orange hue characteristic of red giant stars nearing the end of their life cycle. Like other red giants, Betelgeuse is in the late stages of stellar evolution, having exhausted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It exhibits dark magnetic spots on its surface, which are significantly larger and more numerous than those found on our Sun. These spots are regions of intense magnetic activity that inhibit the flow of hot gases from deeper within the star to its surface, contributing to cooler spots on the star's surface. Betelgeuse's history and cultural significance also make it a prominent celestial object. Known since ancient times, Betelgeuse has been observed and documented by various civilizations throughout history. Its visibility in the night sky, particularly during winter in the northern hemisphere, has made it a prominent feature in constellations and mythology. In recent years, Betelgeuse has garnered increased scientific attention due to its dimming episodes, which began around late 2019 and continued into early 2021. During these periods, the star's brightness dropped to unprecedented levels, sparking speculation among astronomers about its imminent fate. Betelgeuse, also known by its formal name Betelgeuse, is a prominent star in the constellation Orion, located approximately 600 light-years away from Earth. It stands out not only due to its position as one of the brightest stars in the night sky, but also because of its immense size and variability. This supergiant star has captivated astronomers and skywatchers alike for centuries, offering insights into stellar evolution, cosmic distances, and the dynamic nature of the universe. Betelgeuse is a red supergiant, a classification that denotes its advanced stage in stellar evolution. With a diameter roughly 1,000 times that of our Sun, it could easily envelop the orbit of Jupiter if it were placed at the center of our solar system. Despite this size, its mass is estimated to be only 12 to 20 times that of the Sun, reflecting the star's advanced age and the fact that it has shed much of its mass through stellar winds and other processes over time. The star's surface temperature is relatively cool, around 3,500 Kelvin, which gives Betelgeuse its distinctive red hue, a color often associated with stars nearing the end of their life cycle. One of the most remarkable features of Betelgeuse is its variability in brightness. Unlike many stars that maintain a relatively constant brightness, Betelgeuse's light fluctuates regularly, with periods ranging from a few months to several years. This variability is due to the complex interactions within the star, including pulsations caused by the fusion processes in its core and the movement of material in its outer layers. The star's brightness can range from being the 10th brightest in the sky to as low as the 23rd, making it an intriguing object for observation. Betelgeuse's proximity and brightness have made it a subject of extensive study, particularly in recent years. In late 2019 and early 2020, Betelgeuse experienced an unprecedented dimming event, where its brightness dropped by nearly 60%. This event led to widespread speculation that the star might be on the verge of going supernova, a dramatic end-of-life event for supergiant stars. However, subsequent observations suggested that the dimming was likely caused by a combination of factors, including the ejection of material from the star's surface and the formation of a dust cloud that temporarily obscured its light. Despite this, Betelgeuse remains a key candidate for a nearby supernova event, which, when it occurs, will be visible from Earth even in daylight. Betelgeuse, also spelled Betelgeuse, is a quintessential example of a red supergiant star, illustrating the later stages of stellar evolution. Its designation as a supergiant means it has evolved beyond the main sequence phase, where it spent the majority of its life. In this phase, Betelgeuse has undergone significant changes in both size and luminosity. The transition to a red supergiant is a result of complex processes occurring within the star's core and outer layers. During the main sequence phase, a star like Betelgeuse fuses hydrogen into helium in its core. As the hydrogen fuel depletes, the core contracts under gravity, raising its temperature. This increase in temperature allows the star to begin fusing helium into heavier elements like carbon and oxygen. The energy generated from these reactions causes the outer layers to expand, and the star becomes a red supergiant. Betelgeuse, being a red supergiant, has exhausted its core hydrogen and is now fusing heavier elements in its core, while its outer layers continue to expand. The structure of Betelgeuse is particularly intriguing because it showcases a phenomenon known as a stellar envelope. The outer envelope of Betelgeuse is composed of a complex mixture of gases and dust, which interacts with the star's intense magnetic fields. These magnetic fields contribute to the star's dynamic and variable appearance. The outer layers of Betelgeuse are not uniform. They contain various density waves and shock fronts that affect the star's brightness and overall appearance. Another interesting aspect of Betelgeuse is its potential for future observations. As a massive star, Betelgeuse is expected to end its life in a spectacular supernova explosion. This event is a key focus for astronomers because it offers a unique opportunity to study the end stages of stellar evolution and the processes that lead to the formation of neutron stars or black holes. The supernova will not only be a bright event in the sky, but will also provide valuable data on the distribution of heavy elements in the universe. These elements are crucial for the formation of planets and life as we know it. One of the challenges in studying Betelgeuse is its distance. At 600 light-years away, it's difficult to obtain detailed observations of the star's interior processes. However, advancements in astronomical technology, such as the upcoming James Webb Space Telescope, are expected to provide new insights. The James Webb Space Telescope, with its advanced infrared capabilities, will allow scientists to peer through the dust and gas surrounding Betelgeuse and obtain clearer images of its outer layers. This could reveal new information about the star's structure, magnetic field, and the dynamics of its surface. Additionally, Betelgeuse's variability in brightness has led to various hypotheses about the mechanisms driving these changes. Some theories suggest that the star's pulsations are related to changes in the opacity of the outer layers, which can affect how energy is transported from the core to the surface. Other models propose that interactions between different layers of the star's atmosphere could create waves and instabilities that contribute to its brightness fluctuations. The study of Betelgeuse also contributes to our understanding of other red supergiant stars and their life cycles. By comparing Betelgeuse with other similar stars, astronomers can gain insights into the commonalities and differences among these massive stellar objects. This comparative analysis helps refine models of stellar evolution and improve our understanding of how stars of different masses and compositions evolve over time. In the broader context of galactic astronomy, Betelgeuse serves as a key example of the types of stars that influence their surroundings through their life cycles. Supergiant stars like Betelgeuse play a critical role in the synthesis and distribution of heavy elements throughout the galaxy. When Betelgeuse eventually goes supernova, it will release these elements into the interstellar medium, enriching the galactic environment and contributing to the formation of new stars and planetary systems. Furthermore, the study of such massive stars helps scientists understand the potential impacts on surrounding stellar systems. For instance, the radiation and stellar winds from a supergiant like Betelgeuse can affect nearby stars and planetary systems. The energy released during a supernova explosion can also trigger the formation of new stars by compressing surrounding gas clouds. Betelgeuse's prominence in popular culture and scientific research highlights its significance beyond just a celestial object. Its dramatic variability and potential for a supernova event have captured the imagination of both amateur astronomers and scientists. Public interest in stars like Betelgeuse helps raise awareness about the broader field of astronomy and the ongoing research that seeks to unravel the mysteries of the universe. In summary, Betelgeuse is a red supergiant star that provides valuable insights into the life cycles of massive stars and their impact on the universe. Its immense size, variability in brightness, and impending supernova make it a subject of great interest in astronomical research. Advances in observational technology and theoretical models continue to enhance our understanding of such stars and their role in the cosmic ecosystem. As we await further observations and potential discoveries, Betelgeuse remains a captivating object of study in the night sky,